guys, welcome back to my channel. I hope you are all doing great. Today we are going to solve one more Leetcode medium level problem, the smallest number in infinity set. Let's try to understand the problem statement. We will be given one positive integers cut set that is going to be between 1 to 1000. If you look at the constraints, it is going to be between 1 to 1000. So basically we need to implement this class two methods, pop smallest and add back. So pop smallest, the responsibility removes and returns the smallest integer contained in the infinity set. So let's assume initially 1 to 1000 there and user called pop smallest. Then you need to remove one and you need to return it. Then the set is going to hold from 2 to 1000 because one got removed. Then add back. Adds a positive integer num back to the infinity set if it is not already in the infinity set. Let's assume user trying to add one. Yes, he can comfortably add because one is not part of this set. But user trying to add four, he cannot because four is already there. So that's what we need to do basically. So let's see how we can solve. The first approach can be using tree set in the sense. So we are going to hold 1000 elements from 1 to 1000 in the set, and whenever user calls pop smallest, we are going to call poll first, which is a method of tree set. Basically, it helps to removes and returns the lowest element from the set if it is present, otherwise it returns null. Then we can simply execute add method if user trying to add it, and add can only perform if the element is not present. If it is present, it won't add. So that's what we want. So this is leveraging existing what I can say class and the methods. Okay. What are the space and time complexities with this approach? The space complexity is going to be big of one in the sense like constant big of 1000 I mean to say because at most you are going to store the 1000 elements. The time complexity is going to be big of 1 plus big of n to find the what I can say first element. Okay, so that is nothing but big of n. Okay, let's see how we can solve this particular problem. I'm going to take my last submitted one here in order to save the time just. So I'm just copying and pasting. Yeah, here you can see tree set. I just took it and I ran through the loop and I added from 1 to 1000. And whenever user trying to call pop smallest, I executed poll first method of tree set. And whenever user trying to execute add back, then I'm executing the add. Let's give a run. Yeah, submit. Yeah, it got submitted. It took 36 milliseconds. Great, right? But can we bit optimize it instead of storing the 1000 values at first? Can we do in some other approach? Yes, we have another approach. Okay, that is approach number two. Let's see how we are going to do. So with this approach, we are going to have a variable saying like current small. So the goal of this particular variable is to hold the current smallest number which is eligible for pop smallest method. Okay. Okay, I don't want to what I can say make any messy here. So I'm going to have a set. I will tell you why I'm going to have a set. First, we'll walk through one example they given. Okay. So smallest infinity equal to new smallest infinity set. So at first, when constructor calls, I am going to assign current smallest. I'm denoting with CS equal to 1. Okay. The set is empty. Anyhow, here you can see this is set. Okay. Initially it is empty. Now let's come back here. So infinity set add back of 2. So why we need to add 2 here? We no need to add. The reason is even if we add 2 here, let's assume even if we add 2 here, so when the next pop smallest happens, we need to return this one only, not this one, right? Because one is the next smallest element out of the set because one not yet called, right? So when this you not required. Okay, so when the current smallest is greater than number, then only add, then only add. add to set. Otherwise, don't add. The reason is even if you add, that doesn't make any sense for us because the current smallest is still what I can say less than the number, right? Don't add it. So now we are not going to add 2 here. Okay. This called we are not going to add 2 here. We'll come back to that. Next, pop smallest. So pop smallest happened. So when pop smallest happened, every time we check whether the set is empty or it's not. It is empty, right? Then what we are going to do, if it is empty, then what we are going to do is we are going to increment the current small and then we are going to return current small minus 1. Let's see why we are doing in this direction. What is current small 1? When you do plus plus, what is going to happen? The current small is going to be 2. But you are returning what? Current small minus 1. 2 minus 1, that is 1. That is what the expected outcome, right? For the first time when pop smallest called. Yes, you returned 1. Now let's come to the second one. Pop smallest. So this time you need to return 2. Let's see how it is. Since the set is empty, okay, we are going to increment current small. Here's plus plus, that means it will become 3. Then 3 minus 1, that is nothing but 2. We are going to return true. Good. We are on track. Then again pop smallest happened. This time we need to return 3. So since the set is empty, then what we are going to see is plus plus. Then current smallest is going to be 4. We return smallest minus 1, that is nothing but 3. Then add back 1. Now please pay some attention. Add back 1. So here you observe your current smallest is 4 and you are trying to add 1. That is completely okay, right? Because 1 is still less than the what I can say current smallest. That means like current smallest is greater than 1. So you are happily allowed to add it. So if C is greater than num, then add. This is what I said initially, right? So here C is what? 4. Num is what? 1. This condition is satisfied. Then add 1 to what? Set. 1 got added here. That's it. Just hold on. Now pop smallest. When pop smallest called next time, every time we checked whether set empty or it's not, right? If it is empty, then only we did it this approach. But this time is set empty? No, set not empty. Then what we are going to do here is we are going to take the minimum from this set. Okay, we are using set but not reset. That means this set is in unordered way. So what I'm going to do here is I'm going to take min is equals to collections dot min of this set. Okay, then I'm going to have the minimum value out of this set which is eligible for the removal. Then I'm going to remove it. So basically remove this min. Then I'm going to return this min. Done. So I found one which is the minimum and I removed it, I returned it. Then this set is again empty. Okay, cool. The next is again pop smallest. When pop smallest again came, is set empty? Yes. Set empty, that means we need to do this approach, right? So what is the current smallest? Which is 4. Now which is going to be 5. So what we need to do? 5 minus 1, right? CS minus 1. So that is 5 minus 1, that is 4. We return 4. Yes, we got the expected outcome. 4. Then again pop smallest. Again set is empty. Then we choose this approach. So current small is going to be 6. 6 minus 1, that is nothing but 5. We're returning 5. Now we are done with approaching all the things. So this is how you can what can say solve this problem in another way. So now let's try to understand space and time complexities. The space complexity is still going to be big of 1 in the sense like constant. Okay, so we are not going to hold the 1000 elements at once. Okay, we are going to hold some a few numbers. Okay, so that can be less than 1000. That means we know the number. So since it is a big of 1, the time complexity is going to be big of 1 and to perform the constant operations, and collections dot min takes big of n. So that is nothing but big of n. So that's it. Let's try to look at the code. I'm going to take one more submitted one. Please don't mind. In order to save the time of this video, I'm just referencing to the already submitted code. Yeah, you see here I took just a current small which is initially pointing to 0 and a set, And when the constructor called on the object creation, I assigned it to 1 and I made it the implementation of new hash set. Then when pop smallest happened, I check if set is not empty. So initially it is empty. Then I come here, I increment the current small, then it is going to be 2, then current small minus 1, then it is going to be returns 1. If set is not empty, okay, it has some value, let's assume, then we are going to take the minimum from the set and we are going to remove that and we are going to return that. When we are trying to add, it makes sense only if you can add the current small is greater than number. In the sense like current small is 4 and user trying to add 1, then it completely makes sense 1. But your current small is 4, but user trying to add 8. Why you need to add? Because you're not going to return 8 immediately, right? You're going to return 4 only, which is the current small. So that's why this condition. Then let's give a run. Yeah, it ran and let's submit. Yeah, it got submitted successfully and it took 11 milliseconds, which is somehow better than the previous submission and it beats 88.9% of online submissions. So that's all about this video. And if you like my video, don't forget to subscribe and don't forget to share with your known circle. Please do encourage me. I'm going to upload more valuable content in the future. If you find any mistake in this video, please do let me know so that I can correct and I can take precautions when I'm trying to upload the next video. Thanks a lot. Bye.